So far we did a lot of fundamentals. What we're going to do at this point is we're going to take a break from the fundamentals and we're going to put what we learned into practice to making a top-down space game. Okay? So right now, let's go ahead and delete this test script and select our cube. And let's start to take a look at building a very generic spaceship. Okay, now your assignment overall for this class is going to be to build a spaceship in Maya or Max or whatever you like, and then build an enemy and a bullet type. So right now we're going to use very basic things like a cube and a sphere for the projectile and the GUI, but this is your chance to really program an entire game by yourself, put it up on your sites, and have a really nice piece for your portfolio. So inside the assets folder, I'm going to right click and I'm going to create a folder and I'm going to call it models. This is where we're going to put all of our models. And inside of this, I want to create another folder called characters, because maybe you would like to expand it. And then again, another folder, PC for playable characters, another folder called NPCs for non-playable characters. These are where we'll put our monsters. So in the playable characters folder, you create a folder called ship. And in here, I'm going to create a prefab. And I'm going to call it player prefab. Alright? That's what we're going to actually use to connect our cube and all these other things. So, first things first, our cube doesn't have any material on it. So let's right click within that ship folder. Let's create a material. And I'm going to name this player material, and select my cube up top and drag this on top. And let's just make the color for now a green or something, just so it stands out. And I'm going to make it a self-illuminated material, so he pops on the screen. The next thing I want to do is find my camera here, and I want to change in the inspector some of the attributes on it. So for example, I want to make it orthographic, and you can sort of play with the size of your view. Now notice what happened to my cube when I made it orthographic. It what's it called? It became flat, just like an orthographic view. Okay. All right. Instead of free aspect, I'm just going to do 16 by 9, and let's go ahead and move this down here. All right. And again, you can adjust your, when you have your own spaceship made and stuff, you can put it in there or adjust that. Alright, so let's go to the scripts folder and let's create a folder, and we're going to call this player scripts. Alright, and inside of here, let's create a new C# script, and I'm going to call it movement script. Alright, now I'm going to make sure to copy that, because what you'll notice is, because I created the C# script without renaming it right away, you'll notice it's called new behavior script here. And your C# script must match, the name here must match exactly the class name. Okay, so I'm going to go ahead and paste that to movement script. Alright, let me zoom in a little bit. Let's select our main camera. Let's change our background color to black. You can use a photo, or if you want to script some moving asteroids or a particle effect or whatever, you can do that later to adjust the background. Alright, so let's go ahead and open up our movement script. Now the first thing we want to do is, and this is what's really powerful about Unity, is in a couple lines of code, we want to start to kind of program the character's movement. So a lot of times students get scared with the idea of programming in just respect to, like, they always want to know the origin of everything. Now you have to really understand that programming is really, it's a programming language. So you're learning the language on how to do specific things in the C# world. So for example, if you're learning new French, Spanish, Hebrew, Arabic, whatever, you don't necessarily have to trace down the origin of every single word. You just have to understand its meaning and what it might mean to a specific person and the power behind its meaning. And it's same thing when learning a programming language. So for example, if I was going to write the word transform, right? This one's actually pretty easy to understand its origin, because if I click on cube, you can see it says transform here. Okay? And as we move forward, I want to translate, so I will dot translate. And again, if you highlight the transform word here, and you go to help, and you open the Unity API reference, you can see that just by highlighting transform, it'll actually give you all these different like variables that you can use with it in functions. So for example, here's translate. Moves the transform in the direction and distance of translation. So if I write transform.translate and I do open and close parentheses, because this is a function or method. Remember what I told you guys before when we were doing methods and functions. Methods are sometimes called functions. You put an open and close parentheses, and within this there are specific parameters that need to be passed. So translate is pre-made inside of Unity. So for example, one parameter you can write is that you would like to move our ship left and right with the arrow keys. So you write something called vector 3. So if we don't know what a vector 3 is, again, you can highlight it, go to help, open the Unity API reference. It says represents of 3D vectors and points. This structure is used throughout Unity to pass 3D positions. So a 3D position, for those of you who are comfortable with Maya, is X, Y, and Z, and directions around. It also contains functions for doing some vector operations. So again, you just need to know the very basics of what it does and one way to use it. And after you learn the usage of it, you can sort of say, okay, where does it tie into the bigger picture? So vector 3 actually accepts up to 3 parameters, right? And it's the X, Y, and Z. So if I write vector 3 dot, you'll see it'll bring up all this stuff. If I write X, or if I type in right, you can see here's right. I can say I would like to translate my or move this cube in the right direction, which is really just this way, back and forth. Okay. So, but how I move it is, again, when we're writing translate, you're really writing how you want to move it. So I'm going to say times input, this is another class, dot get axis, oops, and then this is another pre-made function, and it's called horizontal. So what is this exactly saying? Well, what it's saying is I'd like to translate this cube along the right axis, or the x-axis. So we can see here as we move this, it's moving on the x-axis. And the way I'm going to do it is by multiplying the amount of pressure by pushing the left and right arrow keys, or A and D. So how do I know that horizontal is attributed to the left and right arrow keys, or the A and D key? Well, if I go up here and I go to edit and I go to project settings and I open input, these are all of the axes for controllers. So for example, if I expand horizontal, you'll notice that it's connected to a joystick, and it's already hard-coded. So let's go up here so you can see this one. The Alt button, so this is kind of a copy of it, but it says here the negative button is A, that's the left, the positive button is D, and it's hooked up to a keyboard or mouse, and you can actually get all motions from a joystick. So if we plugged in an Xbox 360 controller, it would actually work. Alright, so let's go ahead and I'm going to hit Control S to save this. And our cube right now doesn't have this script on it, so I'm going to go ahead and attach it to our cube script. And let's go ahead and press play. And I'm pressing A and D at this point, and you can see my guy moves really quick. Okay, so let's take a look at how we can slow this down. So right now, we're not actually by just leaving it how it is here, by leaving it as is, it's relying on the computer's processor speed. What we want to do is we want to multiply all of this, the speed that it's moving, times the computer's clock time, so that regardless of the computer that we play this on, it'll always be the same. So one way of doing that is multiply this entire statement here, this input.getAxis horizontal. All I'm going to do is inside of here, I'm going to multiply that again, this entire inside statement, times time dot delta time. So now when I could save that and I press play, you can see he moves much, much slower. Alright, let's take a look at one more thing. Let me remove, looks like I copied it twice over. Let's take a look at a way of sort of making a public variable that can actually increase the speed. So outside of our, I guess we could throw it up here in our class. That might make it easier. If you remember from our video on variables a long time ago, the way that you make a variable public is by writing the word static, public, and then the data type. I'm just going to make it an integer, and I'm going to call it ship speed, and I'm just going to put a semicolon there. And what I can say here is I've got all of this here. I can say throw one more, and I could say times ship speed, and I can hit Control S. So if I click back on my cube up here, you can see, let's see if it updated. Oh, you know what? I think I have to add a value to it up here. So let's make this equal to 0. Alright, let's save that. Let's see, maybe if we remove the static, I think that should be right. Oh, there we go, static. Okay, so if you remove the static, static does make your variable available to other scripts, and we'll look at that more later. So here's ship speed. So if I move left and right, you can see he's still super slow. Let's make this 50. It's too fast. Let's knock this down to 10. And that moves a little bit better. That might be the speed we want. Alright, so I'm going to go ahead into Assets folder and make sure that I have a folder called Scenes. You can see we've made one before. And I'm going to save this as ship underscore level 01. And I'm going to save this inside the Scenes folder. Alright, and then in the next video we'll look at coding this a little bit more.